evaluate the following integral. So definite integral from 1 through root 3, 8 arctangent, that means tangent inverse 1 over x dx. For now, let's forget about the limits and 8, because 8 times this 8 can be pulled outside, so I'm gonna just consider the indefinite integral and 8 also outside. 1 root 3 just arctangent or tangent inverse of 1 over x. Okay, and later we multiply by 8, then take limits from 1 through root 3. So here we got tangent inverse 1 over x dx. There is no direct formula where antiderivative of tangent inverse of this has, okay. Then we need to take advantage of integration by parts. That means we just always write this one as u and remaining as dv, and when we have u and dv, then integration by parts formula is ub minus integral of v du. Okay, and let me recall derivative of tangent inverse of some function. Okay, when we find derivative with respect to x, that's 1 over 1 plus u squared times from the chain rule derivative of this inside function, derivative of u with respect to x. And we also know that derivative of 1 over x, we can use the quotient rule, or 1 over x is same as x raised to -1. From the power rule, this happens 1 over x squared, or you can use the quotient rule. But at the end of the day, derivative of 1 over x is -1 over x squared. Okay, here we got u and dv, so we let u be tangent inverse of 1 over x and dv be dx. Now we find derivative with respect to x, du over dx, and I'm going to write dx on the other side. And derivative of tangent inverse of some function using this one is 1 over 1 plus 1 over x quantity squared, which is 1 over x squared, times derivative of inside function, that is -1 over x squared, du over dx. I'm going to write dx here. Now we integrate this, then antiderivative of 1 b equals x. Or we can simplify here, 1 over 1 plus 1 over x squared. We can combine these two fractions on the bottom. That makes x squared plus 1 all over x squared, and this x squared can be pulled to the top. The common denominator on the top, on the bottom, goes to the top over x squared plus 1. Okay, when we simplify this fraction times -1 over x squared dx. Now this x squared on the top, x squared on the bottom can be cancelled. That leaves -1 over, negative can be pulled to the front, 1 over x squared plus 1 dx. Okay, that is du and v is x. Now we can use the integration by parts formula. So now for tangent inverse of 1 over x dx is u dv equals, from the formula uv, u is tangent inverse 1 over x times v, v is x, uv minus integral v times du, v is x, times du is here, -1 over x squared plus 1 dx. Now let's combine this. Okay, do not cancel x and x, because this x is inside parenthesis, means argument of tangent inverse. This x can be pulled to the front. X tangent inverse 1 over x. So this negative can be pulled to the front. The minus, negative means plus. Inside, this is x over x squared plus 1 dx. Okay, now we need to integrate this. And we know that when we have some function, let's say u, and its derivative on the top, 1 with respect to u, then antiderivative of 1 over u is just natural log of u. Okay, so here we have kind of same situation. On the bottom, we have a fractions, there is no quotient rule, so use substitution. But we don't have to show all the work. What we can do is look at the bottom. Bottom is x squared plus 1, whose derivative is 2x. Okay, almost. So we can multiply by 2 and divide by 2, which is same as multiply by 1/2. So 1/2 times 2 is 1, and multiplying by 1 is always legal. So this one is then x tangent inverse 1 over x plus 1/2. Now when I multiply by 2 on the top, I pretty much prepare this formula. U on the bottom, its derivative with respect to x on the top. This is u, its derivative on the top. That means antiderivative is natural log of bottom. So this one, natural log of bottom, x squared plus 1, absolute value, which is not needed, plus c. But we are in the case of definite integral, so I don't write plus c here. And that is just ignoring 8 and limits. Okay, now we need to multiply by 8 and take the limit. Okay, so then 1 through 3, root 3, 8 of this tangent inverse 1 over x dx is, I need to multiply by 8. So this is 8x tangent inverse of 1 over x plus 8 times 1/2. So 8 times 1/2 means 4. 4 natural log of x squared plus 1. X squared plus 1 is always positive because quantity squared plus 1, that's always positive, so I don't need absolute value. And we need to evaluate from 1 through root 3. 1 through root 3. Okay, now we plug in upper limit root 3, then lower limit 1. So plug in root 3. So this is 8 times root 3 tangent inverse of 1 over root 3 plus 4 natural log of root 3 squared, that's 3 plus 1 4. That is upper limit, minus, let's plug in 1. So 8 times 1 is just 8. Tangent inverse of 1 over 1 is just 1, plus 4 natural log of 1 squared, 1 plus 1 2. That's the using lower limit 1. Okay, I could have left 8 outside all the way and multiplied at the end, but it's okay. Now we need to figure out what tangent inverse of 1 over root 3 is and what tangent inverse of 1 is. So from the unit circle, we know that tangent pi over 6, 30 degrees, is root 3 over 3, which is same as 1 over root 3. Okay, tangent pi over 6 is root 3 over 3, which is same as 1 over root 3. That means tangent inverse of 1 over root 3, pi over 6. In the same way, tangent pi over 4 is 1. That means tangent inverse of 1 is pi over 4. So here now this is 8 root 3 times tangent inverse of 1 over root 3 is pi over 6 plus 4 natural log of 4. Natural log of 4 is a decimal number, so I'm not going to do anything. That minus here, because minus means we need to distribute, so I'm going to put parentheses, 8 times tangent inverse of 1 is pi over 4 plus 4 natural log of 2. Natural log of 2 is a decimal number, so I'm just going to leave that there. Okay, so we need to simplify this. We are done. Here we need to distribute this negative. Okay, here we can do something. 2 goes 4 times, 2 goes 3 times, 4 goes once, twice. So this is 4 root 3 pi. 4 root 3 copies of pi. Oh, okay, here is 3 as well. Okay, 4 over 3 root 3 pi. Or, yeah, this is fine. Plus 4 natural log of 4 minus, this is 2 pi, minus plus minus here 4 ln 2. You may leave here. I don't know, we can simplify because that many pi and 2 pi, we can combine these two. And we can also combine these two, but pretty much, I mean, there is no point just combining. Okay, we can combine, but we may leave here, so I'm going to leave here.